Hey gang, welcome back. Hopefully you enjoyed that first video, a little introduction into rotations. Hopefully you get to stay till the end to see Maggie's amazing TikTok capabilities. But in any event, I promised to go through the notes for this, and that's what this portion of this video is going to do. So objective for the day is to be able to rotate an image around the origin. Origin is going to remain our center for this lesson. So let's take a look at this. So far in transformations, we looked at two transformations in the form of a translation, which again was just a slide on the coordinate plane. And again, we could represent that using a coordinate. We also used a vector, and then we also used words. So this was a slide on the coordinate plane. Ugh, that's bad. See if I can fix that. It's hard to write on this. Sorry, I haven't found a better way. So let's see. Slide. On the coordinate plane. So then we also looked at another transformation called a reflection. And again, this is a flip on the coordinate plane. And you always needed a line to flip over. So you could flip over any line. These were just some common lines that we looked at. We flipped over the x-axis. Remember when we did that, the pre-image and the image point, we only changed the vertical motion. So it was the same x value, but it was opposite in y value. Then for the y-axis, now you're moving left to right. So again, the y value stays the same, x value becomes opposite. Flipping it over y is equal to x, remember that's that diagonal lines, that changed the y and the x value. So it kind of flip-flopped those values. And then when you flipped it over, y is equal to negative x, not only did it flip-flop them, but it also changed the sign on both of those. So those were some common lines of reflection that we looked at. You guys got pretty good at that from the work that I've seen. So today we're going to focus in on a rotation. A rotation is a transformation. Definition is a transformation where one point on the plane does not move and everything else moves around it. And that point that does not move, that point is called the center. So again, if I have a plane in the form of this board, and again, I put a point on that board, something like that. Again, that point does not move, but everything around it else is gonna move. So, and again, it can have direction, like me and Joey talked about, but that point or that center of rotation is not gonna move. So let's take a look at fill in the blank down here. To describe a rotation, we need to know three things. And a positive degree measure is one of the things. Again, that's how far you're turning. That's the amount you rotate. You also need a point to rotate about. And then you also need direction. Are you going to go righty-tighty or lefty-loosey, clockwise or counterclockwise? Again, that direction clockwise is the same as a clock. That's how it got its name. It's to the right. It looks like this. So clockwise would go like that in that direction. Counterclockwise, again, it goes against the clock, something like that. So that would be counterclockwise direction. So let's take a look at this. So this kind of illustrates what I'm talking about. So these are different flags, and you're going to have a center of rotation here. The center of rotation obviously is going to be the origin. And so these are flags kind of spinning around that purple dot. So now it wants to describe the rotation, angle, and direction for each transformation. So when I rotate from flag 1 to flag 2, that is this rotation right here. So again, when I go from flag 1 to flag 2, I would say that's 90 degrees. Because that's how far I went. And then went in a counterclockwise direction. So I always go CC for counterclockwise. Now you could think of it in that direction, but you can also think of it as a rotation like this. I could rotate the flag all the way around this way. So there's 90, 180. So I could also think of this as 270 degrees. But instead of going in a counterclockwise direction, now I've gone in a clockwise direction. So let's take a look at the next example. So now I go from flag 1 to flag 3. So here's flag 1, and I want to go to flag 3. So I could go this way, and if I go this way, I'd rotate 90 degrees, 180 degrees, and notice which way I went. I went to the left against the counterclockwise. So this would be a 180 degree. And that was in a counterclockwise direction. Or you could think of this as, okay, I went this way from flag 1 to flag 3. That is also 180 degrees, but I went the other direction, which is clockwise. So often when you're talking about rotation and 180 degree comes up, you don't have to indicate direction because it's same in both directions. You end up with the same thing. So that's often why you'll see 180 degrees without any type of direction associated with it. Another one here is flag 1 to flag 4. Again, still you can think of it as two ways. So we'll do purple again. So flag 1 is here, 4 is here. So the short way would be this way. And that's a 90 degrees clockwise motion. So 90 degrees clockwise. Or you could think of it in the other direction, which would be 90, 180, 270. So that's 270 degrees counterclockwise. And lastly here I got flag 4 to flag 1. So the same two flags, just going from one to the other. And we'll use blue again. So here's flag 4 going to flag 1. I could go this direction 90 degrees, and again that's counterclockwise, so I could think of this as 90 degrees counterclockwise. Or you could think of it as this direction, 90, 180, 270, in a clockwise direction. So that's 270 and clockwise. Note your book and many books. That's what it says down here, rotate in a counterclockwise. So if no indication is given, typically the default is counterclockwise. I tried to mention that in the first video. But again, that is your default, is you're always rotating a clock. That's just so everybody's talking the same direction, and so it's easier. So down here it mentions a 90 degree rotation. Again, that would be in a counterclockwise direction if no mention is made of the direction. It's a common rotation, and the pre-image points would be X, Y. What happens is you flip-flop them, and then the Y changes. So we take the blank of, I would say the opposite of Y, and that becomes our X value. And then X stays the same and becomes the Y value. So opposite of Y and flip for the 90 degree rotation. Then we could also rotate it 180 degrees, 180 degrees about the origin. So again, counterclockwise if nothing else is said. And what happens is if the pre-image point is XY, all you got to do is just change the sign or the X and the Y. Again, so we're going to take the opposite of both X and Y, and there's no flipping involved at 180 degrees. Just the opposite, no flip. And then the 270 degree rotation, again, that would be in a counterclockwise direction. The pre-image point would be XY. Here you're going to flip-flop X and Y again, but instead of changing the sign on the Y, you're changing the sign on the X. So now you're going to take the opposite of X and then put it where the Y goes. And the Y value is untouched. You just put it where the X goes. So opposite of X. So again, if I want to rotate 90 degrees counterclockwise, again, the rule was, whoops, is it down the bottom here? So the rule was flip them and then change the y. So flip and change y. So if I were to do that, let's pick a point here. I got this point P. It's at 1, 2, 3, 1, 2, 3, 4, 5. So that's what, 3, 5 is the pre-image. The image point, remember I would flip these and change the y. So the image point would become -5, 3. So that's for point P. So let's graph that. -1, 2, 3, 4, 5, and then 1, 2, 3 would be right there. So there's your P prime. So let's pick another point. Use a different color here. We'll use Z. Z's at -1, 1, 2, 3. So -1, 3. If that's my pre-image, I would switch them, change the sign of the y. So that would be -3, -1. So -3, 1, 2, 3, -1 is right there. Let's find another one. This looks like a T, so that's at -1, 1. So T's at -1, 1. So we're going to flip them, change the sign on the y value, keep the x the same, and it becomes -1, -1. And then lastly, U we'll do in purple. We'll use it 1, 2, 3, 0. So I can't take the opposite of 0, so it just stays 0, and it becomes 0, 3, which is what? 1, 2, 3 right there. So you end up with this final shape, rotated 90 degrees. About the origin. Again, the center is always going to be origin, so you can see how it is just a rotated about that center point right there. There is another way of doing this, and I'm going to show you that on the next video. I think I'm probably close to 15 minutes on this. So I'm going to start up the next video, and I'll show you another way of doing it. Now, this rigmarole of having to memorize what happens to the pre-image and image points, there's an easy way to do it, and I'll show you how to do that on the next video.